Hi, welcome to Think Human. I'm Chris, and in this video I want to talk about stars, these gigantic, enormous, beautiful, life-giving spheres of gas with billions and billions and billions of them in our universe, and one right pretty close to us, 8 light minutes away. Light takes 8 minutes to get from the sun to the earth. Actually, from the core of the sun, it can take these particles of light, photons, hundreds of thousands of years to get from the core of the sun to the actual surface, and then just 8 minutes for the rest of the trip to get to Earth. So the majority of life, of the light particle that we see with our eyes, actually spends the majority of its life trying to climb out from the dense atmosphere of the sun, the dense core of the sun. Also interesting thing, the particles of light experience no time. Because they're moving at the speed of light, from the moment a photon, the light particle, is born to the moment it reaches your eye or anything else, it's an instant in the perspective of the light particle. So a light particle can move around the universe to billions and billions of light years, but from its own perspective point of view, it experiences no time. Just a fun fact. So with stars, I think the reality of life is that we as human beings take everything for granted. It's this idea of the hedonistic treadmill. No matter what state our life is in, after a little bit of time, we start to take it for granted. We start to look at this as the normality of life. You can win the lottery of millions of dollars or whatever, and then after a year, that's your baseline. That's your normal state of your life. So we're all so used to it, looking at the sky and seeing the sun, at least in countries where you have sun available for you to look at. But still, we get so used to it and everything else, and especially talking about astrophysics, astronomy, it seems so distant. Like the universe, like talking about galaxies and black holes, it's so, I think we're so separated from it. But I think when we think more about these things, it can make us feel more like inclusive with the universe. After all of the atoms and particles that you and I are made of were born from stars. So as stars burn, they generate heavier elements because the pressure and the heat in the core of stars is so high and so dense that they just push atoms together, lighter atoms together, to produce heavier elements, and this is called something nuclear fusion. So fission is how our power plants work right now, so that is splitting atoms, splitting high energy, high mass atoms like uranium. You shoot them with some neutrons, poke them a little bit, then they split apart and they give off energy and light and heat. Nuclear fusion is a reaction where particles, atoms are pushed together, and that generates even more heat and temperature and more energy. So this is what stars are doing. A star is essentially a balance between two forces. The enormous gravity of the star, all of this gas, mostly hydrogen and helium in normal stars, all of this mass wanting to collapse and pull together. But at the core, because of this gravity pushing inwards, all of this matter and mass, this causes this reaction of nuclear fusion. So ongoing nuclear fusion explosion going on in every single star that you see burning, and this produces the opposite effect of pressure outwards. It just wants to explode outwards. So a star is balanced between these two forces, the gravity wanting to push in and the nuclear fusion explosion going on inside the core of the star pushing outwards. And and at the and at the end of the star's lifetime, when it burns up fuel inside its core, this balance is thrown off. So if it runs out of fuel, elements to burn in its core, in its heart, then the pressure outwards starts to slowly decrease, and then the mass of the entire star can collapse inwards, and this produces supernovas, these violent, beautiful explosions where actually most of the heavier elements are created. Gold, platinum, uranium, titanium, all of these aniums and all kinds of other heavy elements that are rare earth elements and essential for our life and civilization are all produced in these enormous explosions. When a supernova explosion happens, it can release more energy in a fraction of a second than entire hundreds of millions of stars in the entire galaxy put together. So one event producing more energy than at the same time hundreds of millions of stars around it, which is pretty mind-blowing. So stars are massive. Our own sun could fit about 1 million Earths inside it, so just incredible volume. I'll try to find a picture that does some justice to this, and also weight of a normal star, because I don't remember it by heart. So there are the smallest stars. Paradoxically, in our universe, the smaller the star is, the longer it lives. The bigger the star is, the faster it dies out. And this is because the small stars actually have something called a convection cycle. So this is a mechanism by which small stars can circulate around the elements and fuel inside it efficiently. So they're really efficient with their fuel. And the smallest stars, these red dwarf stars, can burn for trillions of years. Trillions, up to tens of trillions of years. And our universe has only been here for 13.7 billion years. So these smallest stars are actually in their very infancy and can live for tens and tens and tens of our entire lifetimes of our universe. So these are the stars that will burn the longest after all of the other stars are long gone. These smallest stars will keep burning the longest for trillions of years. On the other hand, the supermassive gigantic stars, which create all the heavier elements, all this chaotic stuff happening, they actually die in a matter of a few million years or a few 100 million years. And this is because they lack the mechanism of recycling their fuel. They don't have convection cycles. So once this relatively small area of the fuel in their core is burnt up, they just explode and produce these enormous supernovas, creating all these heavier elements. So interesting thought that the smallest black holes actually live way longer than the biggest black holes. Now, how I started this video is by saying that we take it all for granted because it seems so distant to us. But I think thinking about it can sort of get us closer to that. And I think, what's the point of living when we can't appreciate the world that we're living in? I think people are too, caught up in these daily lives of these small bubbles, like everything, all there is this small bubble around us. Like, that is not the case. We live in a vast, enormous, beautiful, weird and bizarre universe, and it's fascinating to think about. And stars, these things that give us life, I think it's interesting to know how they work. There are tons of things we still don't know about the sun and other stars. Sun is a star, stars are like a sun. There are tons of things we don't know, but what we do know is fascinating, and I think it's interesting to sort of appreciate how weird the world truly is, and the fact that it's even possible for life to exist. Like, if gravity was any weaker, stars couldn't exist. If the strong nuclear force was any different, nuclear fusion couldn't happen. All the heat, energy, pressure couldn't happen from these nuclear reactions. Everything is so precisely set up in a random kind of way, just in a way that life could exist and evolve. And that, I think, is profound. Not just gravity, not just stars, just that chemistry is able to happen. Like, just the simple fact that we are here able to observe the universe is absolutely mind-blowing, and the probabilities of this is fascinating. I made a video about this, how it might be that we actually live in a sort of multiverse. So the only possible way, well, not the only possible way, but one of the ways to explain how it would be possible that we exist in a universe where we are able to observe it would be that maybe there just is literally infinite amount of them, and we just happen to exist in one that has all the laws of physics, all the material. There's matter and antimatter. Why isn't there more antimatter? So why isn't equally amount of matter and antimatter that you cancel each other out? There are many hundreds and thousands of things. If there were any little bit different, life wouldn't be possible. So I think it's a miracle and fascinating that we're even able to be here and think about it. And it's a shame that more people don't think about it and appreciate it, because once you get into it and thinking about the world around us, it truly is fascinating. So just something I wanted to share with you, how stars work and my little rant and whatever. So I hope it was something interesting for you. If you have any thoughts, please share them in the comments. And of course, thank you so much for watching, and take care.